All right, I want to work some selected problems from 5.12. I noticed some students had trouble today. Um, I'm going to pick some things closer to the end. Sometimes if you look at some of these harder problems, you can go back to some that were earlier on and see how to do them, and I think that's what will happen. I'm going to start with number 21. Number 21, you have 6n squared plus n equal 2. Now remember, when you see a square, usually what we have to do is we try to factor it to solve it. We'll learn some other methods later, but they're not easier. They're actually more taxing, I would say. So I'm going to try to factor this. And in order to factor it and solve it, remember, we have to have 0 on one side, but I don't have 0 on one side. I have 2. Well, how can I turn the 2 into a 0? I could subtract 2. But if I do it to one side, I got to do it to the other. Now remember, I can't combine those terms because they're not alike. So I'm going to have to just do something like this. All right, now, trying to factor this, what do? There's 3 terms, so I know it should factor out like this, right? I've got a couple of choices. One of the things, there's like 3 things to think about. One of them is you could do guess and check, okay? Which may, you got this 6 here, so that means you got lots of different things that could work for 6. 1 and 6, 2 and 3. So there's a lot of things to check. This minus sign here also makes that a little bit more difficult way to work it. You always should check and say, is the first term a square and is the last term a square? Well, this is not a perfect square and that's not a perfect square, so it's not a perfect square. Sometimes that's the easiest way if it works out to factor stuff, but that didn't work out here either. And so our third thing we do is we can do factoring by grouping, and the majority of the class is doing this. That's what I'm going to do to solve this. All right, so if I'm factoring by grouping, I'm taking advantage of some things I already know how to do. I'm trying to multiply. Instead of to just get the number on the end, I got to take this 6 that I underlined in red and the negative 2 at the end. It's the coefficient of the first term and the constant term, and I multiply them. I'm trying to multiply to get negative 12, and then I'm trying to still add to get the number in the middle. And you may say there's no number, but remember, there is a positive 1 that the lazy math guy didn't write. When you see it this way, you go, oh, I can break, what I'm trying to do, if you remember when I do this, is break this middle term up so that I can actually factor it. So if you think about it, 4 times 3 would give me a 12. I need a negative because I need a positive and a negative to multiply to give me this negative on the 12. How could I adjust it to get 4 and 3 to equal 1? What if I made the 3 minus? 4 minus 3 is 1, or 4 plus negative 3 is 1. 4 times negative 3 is negative 12. So what I'm going to do is rewrite this 6n squared, but instead of writing 1n, I'm going to split it up. I'm going to say, oh, I can make a 1n by saying a plus 4, remember I got to put the n on it, minus 3 from over here, n, and then I've got minus 2 equals 0. And then I can do factoring by grouping. I can group these 2 and these 2. Sorry, I actually underlined the 0. If you remember what we did then is we said, okay, what's the GCF of 6n squared plus 4n? The biggest thing that divides out is a 2 and an n, and that would leave me with 3n plus 2. Now, when I get to the second set of terms, anytime I see a subtraction sign right here, I'm going to factor out a negative. And if I look at negative 3n and negative 2, there's nothing else that divides out, but I can take a factor the negative out of it. And so if I divide negative 3n by negative 1, I get a positive 3n. If I divide negative 2 by negative 1, I get a positive 2. Do you see why I wanted to do that now? Do you remember that these two things have to match? Because my next step is to say, what's the GCF of this term and this term? Well, the GCF is 3n plus 2. And what are my leftovers? Well, if I pull this thing that they both had in common out, my leftovers are just this 2n and this minus 1, and we're done. We have factored that one. So this was a harder one to factor because the number in front of the square was not just a 1, an invisible 1. That made it harder. And the other thing was we had to remember that all the terms have to get to move over to one side in order for us to be able to have a 0 on the other side so that we can solve it. We cannot solve it if we don't have 0 on the other side. Okay, I thought I would move to 27 next. These are just ones that people have told me they had trouble with, so I wanted to kind of address them. All right, we got 2 terms here. Now, the first thing I should always do is check for a GCF, because a lot of times once I pull that out, it becomes clearer to me what I need to do. Both of these terms can be divisible by 2, and both of them have at least u squared that we can take out of them. So that's my GCF, and now I'm going to write my leftovers. And when I do that, I'll be able to set each of these factors equal to 0, and I'll be able to solve. Okay, so the first term, if I have 8 divided by 2, I have 4 left over. U cubed, take out u squared, there's a u left over. I could look at it this way. I could say negative 2u squared divided by 2u squared. Negative 2 divided by 2 is a negative 1, and I'll write that as a minus 1. U squared divided by u squared, oh, that's also 1. I could have also copied down the subtraction sign and said 2 divided by 2 is 1, or 2u squared divided by 2u squared is 1. There's lots of ways to think about that. All right, I've got my two factors. So I set each factor equal to 0. Even though it's not in parentheses, this is still a factor here. This 2u squared is still a factor. So you want to set it equal to 0, okay? And then I want to set the 4u minus 1 is equal to 0. So I'm going to have two answers. If I divide each side by 2, I get u squared is 0. Square root both sides, oh, u is still 0. So there's one answer. Over here, if I add one, I'm trying to solve for u. Remember, we want to know what the variable is. That's why we're solving for u. I get 4u is 1. And if I want to get u by itself, it's multiplied by 4, and the opposite of multiplying by 4 is dividing by 4. So here's my other answer. U is a fourth. All right, 31 gave a few people some problems, so I thought we'd look at it. And again, the reason this one's hard is that it's not just a regular old y squared. There's this 8 in front of it, and anytime there's a number in front of the square and you can't take it out as a GCF, it's a little bit harder problem. And so your choices are, you can first check to see, do you have a perfect square there? Is that first term a perfect square? No, it's not, so that's not going to work out for me. I have two options here. I could guess and check. Probably wouldn't be too bad, and some of you like that. And the other thing is to factor by grouping, which a lot of you have preferred. So again, that's what I'm going to do here, is work it that way, since most of you are trying to work your problems that way. Now when I factor by group, you remember the idea is that I'm rewriting the middle term in a way that lets me use factoring by grouping to solve the problem. And in order to do that, though, I have to think. I'm trying to multiply to get, what do I multiply? The number on the end, the constant, and the coefficient of the first term. 1 times 8 is 8. And at the same time, I'm trying to add to get this number in the middle, negative 9. Okay? Now, if you think about it, 8 times 1 is 8, but if I add them, I get positive 9. Couldn't I make them both negative? And negative times a negative, negative 8 times negative 1 is a positive 8. Negative 8 plus negative 1 is negative 9. So I could do that. That's going to work. So what do? I rewrite my first term, but instead of writing minus 9y, I'm going to write it as minus 8y. I'm going to use this. And then minus 1y, which is this. I could have put just minus y. I'm just going to put the 1 in. And then I write my plus 1 down. I kept my first and last terms, and I just rewrote my middle term. All right, if you remember what happens next is we group things together. We're going to group those two terms together and these two terms together. So if you look at the first set of terms, the GCF, the thing that divides out of both of them, would be 8y. And my leftovers will be 8y squared. 8 divided by 8 is 1y squared, and divided by y is 1y left over. And if I look at it as negative 8y divided by 8y, that would be negative 1 left. Now when I get down here, and I always remember when I have this subtraction term in this spot, I want to factor that negative 1 out. And if you look, there's nothing else that divides out anyway. So I'm going to factor out a negative 1. And I'm going to write the leftovers in those parentheses. Negative 1y divided by negative 1 is a positive y. Positive 1 divided by negative 1 is a negative 1. Oh, this is good, because when we factor by grouping, do factor by grouping, we're always supposed to have the same things in the parentheses, because that's what makes it work, right? And we do. Out of those two terms, we have a y minus 1 that would divide out, and our leftovers would be that 8y that's out front here and this minus 1 here. I'm almost done. And I didn't have to sit there and guess and check and maybe spend a lot of time getting frustrated, but again, that's easier for some people, so it's not wrong to do, it's just easier for some people. So I set y minus 1 equal to 0. and I set the other factor equal to 0, these will give me my two answers. And again, I know that I should probably get two answers because there's a square on it, so there's at least a possibility there's as many as two answers. Sometimes there's only one, but we'll talk about that another time. If I solve for y here, I add 1 to both sides. I get y equal 1. There's one of my answers. If I solve for 1 over here, I'll move the 1 to the other side because we always add or subtract first. I now have 8y equal 1. If I want to get y by itself, I can divide both sides by 8. And I get my other answer, y is 1 over 8. I also want to look at 35 just because I've been kind of pointing out that there's three things to think about on some of these problems, and so far I've brought up one way that's never worked, and I wanted to work one problem where it actually did work. All right, so I look at this problem, and first of all, I know that if I want to solve it, and that's what they asked me to do, I need a 0 on one side. So let me do this. Let me subtract this term from both sides. And remember, it's not going to combine with anything over there on the left, but it adds up to 0. Okay, so what I have is 4p squared minus 44p plus 121. We always want to put it in the right order. Biggest exponent down to smallest, and then the constant is last. Now, there's no GCF that divides out of that, and I go, uh-oh, this is a harder factoring problem because there's a 4 out front, and if you remember, my options were guess and check. And I could try factoring by grouping, which these would work here, but there's an easier way to do this one. And it's something you should always check to see, and is see if it's a perfect square binomial. I'm thinking that's back in section, I want to say 5.6 or something like that, okay? It was back earlier in this chapter. If you look at if the first term can be written as a perfect square, and it can, it's 2p squared. And if the last term can be written as a perfect square, and it can, it's 11 squared. If you remember, if I take what's inside of there, the 2p and the 11, and I multiply them together, I get 22p. If I double it, and it's equal to the middle term, 44p, aha, I got a 44p there, I can factor this in an easier way. I don't have to kind of go through all the stuff that I did on the other problems. Now, it's almost the middle term, but it should be negative. How am I going to get a negative 44p? What if I put a minus right here in front of the 11? 2p times negative 11 would be negative 22p, and 2 times negative 22p would be negative 44p. So I can just kind of adjust it a little bit. So the easy way to factor this is just to put 2p minus 11 squared. And remember, that's the same thing as saying 2p minus 11 times 2p minus 11. If you don't believe that's right, multiply this out and you'll see that you get this back. So if you check and you got perfect squares on the first and the last term, you still have to check to make sure that if you multiply this stuff that you squared, you multiply it and then double it. If it equals a middle term, you can factor that one a lot quicker than maybe using the other two methods.